Okay, so how to find eigenvalues when we have an equation that looks like this. I'm sure you can see. Let me just stop moving. Okay, not sure if you see that. We have a differential equation with a few terms in it, right? We want to turn that into a matrix right here, right? And the reason why we do that is because we're going to get this form, right? Oh, by the way, dx over dt is just x prime, dy over dt, y prime, and so on. But we turn into this because we want to use this equation, right? I'm going to call this, or actually first, let me say, we want something that looks like this. Go here. Yeah. Let's call that big X of t is equal to small x of t, y t, z of t, right? Right, so we want this, right? And then we're going to use this formula right here. X prime is equal to ax. Now our a is this big old guy right here, right? This is our a up here. Okay, if you can see, right over here. So after we turn our system of differential equations into a matrix, what we want to do next is we want to find our lambdas, right? And here's another useful equation. So basically, the determinant, or the det, pretty sure it means determinant, of a minus lambda I, right, is equal to 0. Now, what I think I is it's like the, not the personality, but just like the shape, right? The fucking, the shape of, where lambda is gonna be. Like it's gonna be a diagonal. It's gonna look like lambda, lambda, lambda. Like this is like that's our eye, right? That's our shape, right? Yeah. So what we want to do here is we want to take our a and subtract it by lambda times our shape, right? So that's gonna look something like so basically, since we have this diagonal pattern, we're just going to fill in all these diagonal zeros with lambdas. So this is what we're going to end up getting. We get my black pen. We're going to get, and sorry, I'm a little rushed. I'm kind of making this last minute. We have a matrix. We're going to put in our lambda. Oh, that is a terrible pen. Let's use cool blue. But you know what? I'm going to pause right there. All right, just take a look at that while I write. We're going to do lambda 6, 0, 1, and oh, and it's going to be minus lambda. My apologies, because we're subtracting lambda I, right? So that's why we're going to have this minus lambda. Let's see, that's 1, this is 1, 1. Okay, great. So, you know, what does this mean, right? So notice here how this entire determinant is equal to 0. It's all equals 0. So, basically what we're going to do is we're going to solve this determinant, right? And I'm sure you remember it's like vectors, right? When you're trying to find like a cross product, right? So we basically have lambda times, let me get out of your way. We have lambda times lambda squared, 1 times 1 plus, oh, minus, my apologies, minus 1. And then we're going to have minus 6 times 1 times minus lambda, it's going to be minus lambda. And then minus 1, hold on, wait, yeah, minus 1 equals 0. Let's see, can you still see that? Yeah. Okay, and then once we combine everything, we're going to end up with this negative lambda cubed minus, no, plus lambda plus 6 lambda plus 6. Just check. Yep. Okay. We're going to add it all together, and since we don't really like negative for the highest coefficient, we're just going to make this lambda cubed minus 7 lambda minus 6 equals 0, right? And then our next step is going to be factoring this. So what does that give us? Oh, yeah. Okay, yeah. It actually fucking sucks factoring this. You have to use, what do you call it? You have to use synthetic division and then the GCF or something like that. So yeah, so basically the way you're going to factor this is you're going to have plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, right? And then you're just going to knock out those that synthetic division, right? I got lucky and I hit it on my second try. So I used -2, right? And if you want to find the factors of this a different way, I'm sure you could, but this is just what always works for me. So, we have -2. Let's see, can you see that? Oh, no, you can't. Okay, hold on. Come back over here. Thank you. Okay, I want you to stop moving. Okay, cool. So can you see that? Okay, so what we have is, so we're going to put 1, hold on. Okay, 1, -7, and then -6. And then I got lucky, so we have a -2 here. We'll bring the 1 down, right? That goes down. -2 times 1, -2, -2. Wait, hold on. Oh, okay. So 0 minus -2, -2, -2 times -2 is 4. We get -3. -2 times -3 is 6, right? Then we get a 0. So that factors nicely. So we know that one of our factors, one of our little motherfuckers, is maybe a +2. Hold on, get this shit right. Yeah, use +2. Right. Hold on, let me. I always get confused, when using something. I'm pretty sure it's a +2 because we use -2. I forget if that's how it works. Oh no. Let me go consult the oracle. It's right there. Okay. I know I got confused. So it's going to be +2, but but obviously since our lambda is going to be -2. That was my thing. I got confused with my stuff. But anyways, so we know that this is one of the factors of this. So then we could divide this by, oh, not that. My bad. We could divide, what is this? This is going to be lambda cubed minus 2 lambda squared minus 3 lambda, right? Divide that by lambda plus 2. Right. And then, that breaks apart nicely into what do you call it? Oh wait, no, we don't need to divide that because we already divided this, and so that is our output. So now we just got to find the factors. They should be like this. But that just breaks easily into. Let me just write our lambdas. So we have lambda plus 2, lambda minus 3, and then lambda minus 1. Okay, so that means our lambdas are, we're going to say, actually follow me over here. Follow me over here, okay. Got more space over here. Okay, right there. Yep. Okay. So now we have, let's see, right here. So we have our lambda 1 is equal to 3. Our lambda 2 is equal to, wait, what the fuck? What the fuck, I did something wrong. Hold up. Okay. Okay. That should be equal to -2. It is a +1. Maybe I lied to you guys. Okay, that makes sense with my final solution. Okay, anyways, so these are our lambdas, right? The next step is, let's look back at this, right? So we found our lambdas. Now we just need to plug our lambdas into this equation. So one of our lambdas is 3, right? So we're going to have, actually come here, stop moving. Okay, so we're going to have this matrix. That's going to be -3, 6, 0, 1, -3, 1, 1, 1, -3. Okay, so now that we have this has to equal 0, right? Because we have to keep going back to our this function up here. We have to, over here. We have to keep going back to this function, right? Or not function, but this what's it called? This formula, right? So let's come back. Stop. I said stop. Stop moving. Thank you. Okay. But yeah. So we plug in our lambda 3, right? Now we could like move this around, we could like mix it up a little bit so it's easier for us. I'm kind of a knucklehead, and I don't really trust myself with matrix multiplication yet. I haven't done linear algebra, so I'm not an expert on this. So I just like to turn into a system of equations, right? So I'm going to skip a step for the sake of time, but I'll show you how to do this, right? So what we have is, we're going to say, actually come over here, come down here, and I think a little to the side. Stop. Good, okay. So what we're going to do is we're going to make a system of equations. People like to use x1, x2, x3, or something of that sort. I like to just use a, b, and c's. So we're going to say -3a plus 6b equals 0. Okay. And then we're going to continue, right? So over here, this is going to be a minus 3b plus c equals 0. Then we have a plus b minus 3c. Okay. So let's try to solve these. So what we're going to have next is we're going to have 6b is equal to 3a, right? So that means 2b is equal to a, right? When you use that into our next equation, right? Just make a little space here. And then we're going to have, let's write it in this pen. So a equals 2b, so we'll have 2b 2b minus 3b plus c equals 0, right? So obviously 2 minus 3 is negative b. We'll remove that c to the other side. So b is equal to c. Nice. Okay, so this basically just, we kind of know everything right now, right? So to make our lives easier, let's just say that c is equal to 1, right? So if c is 1, b is also 1. And then what makes a? A has to be 2. So what we end up getting is, I forgot to explain a really important step. So this actually isn't that simple. I fucking lied to you. It's actually, it actually looks like this, right? So some vector is being multiplied against this, that gives us 0, right? And that's what we're trying to find, and that's what we did just find. And that vector ended up being 2, 1, 1, right? Yeah. Okay. So this is our first one, right? I could help you and keep going to the next ones, but I'm severely running out of time. But you know what? I believe in you. You could do it. You could solve those other ones. You know, all you got to do is plug in your lambdas and then do some system of equations. It is kind of confusing. I should probably do another one with you, but you know, let's go back over it. Let's go back over it. So, you know, solving, so it's kind of like, I mean, you've done partial fractions, right? Like, you know how you kind of just let x be anything? It's kind of the same shit. So it's like, you have 6b equals 3a, right? This is just, you know, we get that from this equation, right? And we could plug it back into there, right? And then we just get b equals c. And what you choose is kind of arbitrary, right? Because you have to remember that these are vectors. So as long as they have the same, what's the word? Like the same relationship. Like if they're just like scalar multiples of each other, they're still the same vector, right? So it you know, you could have chose 2 and it would have been the same. But 1 is easy. 1 makes your life easy. So let's pretend you did the work. Pause the video, do the work, and then yeah. Okay. Are you back? Did you pause it? Or are you cheating? Waiting for the answers. Okay, so this was from lambda 1, or lambda 2 vector is going to be, let's see, negative 6, 1, and 5. Now, I'm hoping I did this right. If I'm wrong, please correct me. I'm pretty sure I got this final answer right, but we'll see. This is our lambda 2 vector, and then our lambda 3 vector, negative 2, okay. And our lambda 3 vector was negative 3, 1, 1, right? Okay, so cool. These are eigenvalues, right? Or eigenvectors. I actually don't know. I just learned this, so. You know, you're probably smarter than me. You could probably do this. But yeah, these are our eigenmajiggers. And what's cool is that we could just plug this back into our differential equation. So like, they just go right next to our, let's write the answer here. Oh shit. Doesn't want to follow me anymore. Come on, follow me right here. Give me 1 sec. Alright, do you want to follow me now? We cool? We good? Alright, cool. Okay, we're good. Alright, so we have our eigenvalues. You know, I wonder if they're eigenvectors. They're probably eigenvectors because they're in that little, what's it, that bracket thing? I think. Not sure, but I'm going to read up on that after. But anyways, we just plug this next to our C's, right? So just like normal, our x of t is equal to c1. Actually, I'm going to leave a little space so you can see how cool it is. Because you know it's just like solving for normal differential equations, right? For C1 e to the 3t, right? Because that's what our lambda was equal to. But we put this little bracket here, and then we get, what was it? We had a 2, 1, 1 for our first eigenvalue, plus C2. Oh shit. The people with OCD are going to hate me, so let me write down the eigenvalue. -6, 1, and 5. And then we had -1, so e to the -t, plus C3. Oh, did it again, and I also forgot the constant. Okay, C2, e to the -t, plus the next eigenvalue. We have -3, 1, and 1. Good stuff, good stuff. Write C3 there. E to the -2t. Right, and so then this is our answer, right? So let's just do a quick walkthrough of what we did real quick. So we have a system of linear differential equations. We turn this into a matrix, right? And the reason why it's 0, 6, 0 is because you have to think of it as like x, y, and z, right? So nothing in the x, right? I should explain this earlier, but nothing in the x, only in a 6 in the y, and a 0 in the z. Same thing with this one, right? Only an x and z, 1, 0, 1. Then we have an x and y, 1, 1, 0. Okay, cool. We turn this into big X of t. I don't know why I did this. This is just what the internet said. So now we're sticking with big old bold X, right? Big old bold X of X of t, y of t, z of t, right? We look at this equation right here. There's actually a way to differentiate it. I think I didn't write down the exact formula. My bad, but you can search it up. I believe in you. And then we get to this determinant of a minus lambda I is equal to 0. And the fact that it equals 0 is one of the biggest parts, right? Because in order to get these lambdas, we have to find what vector makes it all 0. So yeah, but before we get to there, we have to find the lambda, right? And we plug in our lambdas in a diagonal direction. That represents our I. And again, this represents our A. Plug in all the lambdas, do your algebra, factor it out, do your synthetic, your GCF, you get your lambdas, come back, put the lambdas, right, over here. Hold on, over here. I keep blocking it. Here, just stay still. Okay. Yeah, get your lambdas. And then after you get your lambdas, do your magic, do your system of equations. Try to find what makes this matrix paired with the lambda 0. And then yeah, that's how you get your eigenvalues next to your C1, C2, C3 for differential equations. I hope this was helpful. Sorry it was a little bit messy. Let's see, I have 28 minutes before I have to turn this in, so that's why it's a little crazy. Yeah. Anyways, see you later. Have a good one.